The buildings of Parco Fenice, the renewable energy park, are located in the middle of a park near Padua. It represents a model of excellence and testing of various energy-saving technologies and the production of energy from renewable and/or alternative sources. For the construction of these structures were used the most modern technological and standards construction and the concepts of passive house and eco-labeling. Application and technology used mixed results and innovation, creating sustainable solutions, technology templates exportable abroad. Founded in 2005 by the Consorzio Zone Industriale of Padua and by Scout National Body, section of Italians Young Explorers, Phoenix Foundation combines volunteering undertaking to promote environmental education and testing of environmental systems, with the support of Fondazione Cassa di Risparmio of Padua and Rovigo. The hostel was isolated with a layer of polystyrene 12 cm thick. When you try to knock on the wall behind the bricklayer mortar, you can hear if as there were nothing. This is the so-called outside coating. Here, in Renewable Energy Fenice Park, there are some other kinds of insulation technologies. For example, you can find Selenites and Stiferites products. The training center was isolated with a layer of mineral wool, 10 cm thick. If you notice, you can see that these walls are thicker than traditional buildings because of insulation. The common bricklaying mortar that combines the building bricks of our homes is a poor insulator. To overcome this inconvenience, the buildings of Parco Fenice use a special glue. After solidification, it appears as in the picture. The bricks of the two buildings are different from the classic perforated. In fact, Poroton is a special brick lightened by spherical air cavities. Obviously, the lightening involves a change in the thermophysical characteristics of the brick. In fact, in standard condition, a lightweight material is thermally more resistant than a heavy material. Now we are in the hostel. Under the floor there are a lot of recycled plastic igloo-shaped blocks. We created a crawl space, an air layer which increases the insulation. In the training center, you do not find heating radiators, except for bathroom. The water, heated by the geothermal plant, from boiler goes into this tube, placed under the floor. So the house is uniformly heated, saving about 30%. Although now we see double glazing windows in all houses, their importance in energy efficiency remains high, and increasing the number of glasses can only improve. The double layer of air among the three glasses prevents the condensation formed by cold inside the building. The roof tiles that protect the two buildings are scattered by titanium dioxide, a photocatalyst substance which, in contact with the sunlight, helps to reduce the city pollutants. We are in the training center, and behind me you can see the geothermal system. In our educational park, we have chosen to expose our technologies as a visiting card. All operating data of the plants are constantly monitored and are accessible from the control panel. In front of the training center, there are 8 U geothermal that go down to 100 meters deep, where the ground has a constant temperature. In these probes, there's a fluid that flows and absorbs heat from the ground. Then, it exchanges it in the heat pump to heat the structure. During summer, it can also be used to cool the rooms. The heating pump works in 4 phases: evaporation, compression, condensation and expansion. During evaporation, the fluid coming from the probes, circuit A, transfers the heat to the evaporator, where the water inside evaporates, circuit B. In compression phase, the low-pressure steam is compressed, increasing its pressure and temperature. Condensation. During the condensation, the high-pressure steam transfers heat to the water of the circuit C, which reaches a temperature of about 40 Celsius degrees and supplies the floor heating. At the end, in expansion phase, the steam condenses and passes through an expansion valve where its temperature is lowered, and then resumes the cycle evaporator. The water heated by the solar panel flows in a closed circuit that passes into a water tank called boiler. This hot water may be used in the toilet facilities. In support of the solar heat, there is a gas boiler that starts working when the hot water demand is high. In autumn, in a solar thermal system, the water can reach up to 60 Celsius degrees, and this is a big saving. The heated water produced by our 9 panels is used for heating domestic hot water of the training center and of the hostel. Behind me, there is the training center's photovoltaic system. The 24 photovoltaic modules provide a maximum output of 4.5 kilowatts, thus 1 kilowatt more than normal domestic consume. The modules are made of polycrystalline silicon and are oriented at 30 degrees south. They have an efficiency of around 13%, and the trend of the production is detected by the monitoring system connected to the video. A toilet uses from 4 or 5 to 10 liters of drinkable water. To avoid this big waste, we forced the rainwater from the roof to an underground tank. That water can be also used for gardening and not drinkable uses. This is Visitor Center, the first structure built in Parco Fenice in 2007. What is this trapdoor? Under the floor there is air. In fact, this gap allowed to keep the construction isolating from moisture below, making it more efficient. The only source of heating of the visitor center is this pellet stove. Thanks to the wooden walls, the double-glazed windows and underfloor insulating system, the visitor center is certified B class, which means that it dissipates very little power.